Now in this video, we're going to look at r-permutation of n elements. In previous video, we just talked about an n permutation. What's the difference? So the example that I gave before was, say I have we have 3 people, and we have 3 seats, and we want to award three presentations, and so n equals 3, and so we have to schedule presentation for the 3 people. So we call this 3 permutation. And we know 3 permutation is the number of permutation for 3 people is 3 factorial, which equals 6. But what if I have, say, n people, different from, say I have 5 people, but I only want to choose 3 people to do the presentation. So in this case, the difference is we have 3 people, and all these 3 people will do a presentation. Well, we have 3 chairs, all these 3 people will have chairs to do. But the different case is I may have more people than the number of chairs, or I have more people than the number of presentations I need. So in that case, this is called a 3 permutation of 5 elements. And you could do 3 permutation of 3 elements. That would just be 3 factorial. So previously we didn't say that, but it's like 3 out of 3. But now we're doing 3 permutation out of 5 elements. So what's the difference? Again, we are going to start. We're going to use the multiplication rule to do that. So this time I only have 3 time slots, but I have 5 people, so I can only choose 3 of them to do the presentation. Or I may have 3 chairs. Let's number then first chair, second chair, and third chair. But I have 5 people, so that means I can only choose 3 people to sit on the chairs. So start with the first chair. Again, we have 5 people, so you can choose any of these 5 people. That gives us 5 options. For the second chair, or the second time slot, since again, one person, we're not going to allow this person to do presentation twice, or one person cannot sit on 2 chairs. And so if the first person already got the chair, and then out of these 5 people, there's only 4 people left. So we can pick one of these 4 people, one of them, to sit on the second chair. And the similarly for the third chair or third time slot, because we have already chosen 2 people out of these 5 people. We only have 3 people left. We're going to pick one of them. There are 3 options for us to pick a person for the third chair or third time slot. And then we're going to use multiplication rule to multiply them. So that gives us 60 different ways to assign these, to pick 3 people to sit on the 5 chair, or pick 3 people to do 3 presentations out of 5. And the difference, as you can see, we cannot write 5 times 4 times 3 as a factorial anymore, because it doesn't go down all the way to 1. Previously, 3 people, 3 chairs, you always go down to 1. First person, second person, and last person, you have 1 left. So that's why it's always a factorial, n factorial. But now it's not. So one way to write it, if you notice, look for the pattern. So what's 3 permutation of 5 people? First of all, let's look at the symbol, so it makes it a little easier for us to write. We can write the permutation as using this symbol. P means permutation, and parentheses, we have 5 people, we choose 3 to do presentation. So it's 3 permutation of 5 people, 5 elements. And what's the formula? As you can see, we start with at the beginning, we still have 5 options. You always start with the bigger number, 5, and then times, decrease by 1, and decrease by 1, and then we stop at the 3. And notice that when do we stop? If you have, because we choose 3 people, that means you have to have 3 numbers, so you can stop. So the last number, what would be the last number? Notice that the last number is exactly 5 minus 3 plus 1, because 3 is equal to 5 minus 3 plus 1. If you do 5 minus 3, that gives us 2, but we actually need to add 1 to get that 3. And so that's, in general, the formula will be, the first chair, we have n people to choose, so there are n options. And the second chair, since we use the one person, the first person, the one with the person already has a seat, and then we have n minus 1 choices, and then continue to decrease it all the way down to one number. What's the last number? So that's the important thing. The last number is not going to be n minus r, it's n minus r plus 1. So we got to add 1 to it. From here we saw the pattern. So in general, say if suppose I have 7 people, I want to choose 4, and it's going to be by using this formula, which is given right here. And you start with from 7 and down to 6 to 5. When do I stop? We're going to stop at n is 7, r is 4, so 7 minus 4 plus 1, which is 4. So we're going to start, last number should be 4. And we can verify that this is true, because 4 tells us we have 4 chairs. So 7 means we have 7 people. So the first chair has 7 options. Second chair we have 6 options. And third chair we have 5 options. And fourth chair we have 4 options. And see, we always stop at n minus r plus 1. And we can work this out to get a answer. We have 840 different ways. You can use calculator to do that. So this is 4 permutation of 7 elements. And there is another formula given, an equivalent formula given. So if you think this formula is hard to remember, and well, one way is you can always go back to multiplication rule, because this is technically multiplication rule. But if you don't like this formula, there's another version which might be a little easier to memorize. The top is start with the big number, n factorial. The bottom is the difference of n minus r factorial. In this way, you don't have to remember that little plus 1 there. So why is that? So we can look at the example here. Say 5 times 4 times 3. This pretty much, the reason we cannot write this as a factorial because it doesn't go down to 1. But if I multiply it by 2 and 1, and this will become a factorial. But if I multiply it, I would change the answer, change the number, so I can divide it by what I multiplied. Notice if I cancel, then we still go back to 5 times 4 times 3. But in this way, so this is the same as after I multiply 2 times 2 times 1 on the top and the bottom, it's going to be the same as 5 times 4 times 3. So there's no difference. But this way, in this way, the top becomes a perfect factorial, which is 5 factorial. And the bottom is also factorial of 2 factorial. So that's why we can write 5 times 4 times 3 as 5 factorial divided by 2 factorial. So this is a 5 factorial on the top and 2 factorial on the bottom. So that's they are equivalent. So similarly, in general case, and again, this formula is not very easy to remember. So what we can do is let's just go ahead and multiply by, times it by, say, continue m minus r, and then continue dot 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 all the way down to 1. But if we multiply that, we also have to divide by the same thing, so we won't change that number, original number. And then look at the top, since we go from n, multiply n all the way down to 1, that top is exactly n factorial. And the bottom, we start from n minus r, because the one, if you reduce this number by 1, you're going to get n minus r. Subtract 1, this 1 cancels. And the bottom is exactly n minus, we multiply numbers from 1 all the way to n minus r, that's n minus r factorial. So that matches the bottom. So this is a different formula to memorize for the r permutation. So just pick the formula you like, and the worst case is you forgot both formulas, and you just have to start to use multiplication law to do this problem again. I want to pick 5 digits. Pick 5 digits, either like a security code or 5 digits of a number, a telephone number. But usually a telephone number here we have say 7 digits, but we have 10 digits, but it could be if you want to do a random case of any number of digits. And let's just make it like a security code. We have we want to pick 5 digits as our security code, but we're not going to use the same number twice. So no repetition. And notice that that's one of the properties of permutation. We cannot use a person twice, or one person cannot sit on 2 chairs, or one person cannot do presentation twice. So no repetition. And then there's order, because when you do the passcode, the password, that 1 2 3 4 5 will be different. If you put in 2 1 3 4 5, that will be wrong. You cannot log into your account. So the order does matter, and that's again the property of permutation. So let's see how many options do we have. Well, if you remember the permutation formula, this is exactly a permutation. We have 10 digits we can choose from, 0, 1, 2, 3, 4, all the way to 9. But we only want to choose 5 of them. We don't need to use all of them because we only have 5 digits. So that's exactly P10, 5, a permutation of P10, 5. And when we work this out, you could do either way, say 10 times 9 times 8. All the way, remember the last digit is 10 minus 5 plus 1, so that we should stop at 6. Or if you want to use the other formula, the top is 10 factorial, the bottom is 10 minus 5 factorial, 10 minus 5 factorial. So either way, you should get the same answer. So if we do 10 factorial on the top, you still have to expand it to get 10, 9, 8, all the way down to 1. On the bottom, because this can be simplified to 5 factorial, so it's 5 times 4 all the way down to 1. And notice that they share this same thing. They can be cancelled. After you cancel, then you can see it goes back to that. So really, the first formula is easier to do calculation, but the second formula is easier to memorize. So you can work this out to get a answer. I can skip that. I will skip that here. Use a calculator to do that. Now let's look at the second question. If we want to have at least one repeated digit, So what does this mean? At least one repeated digit. You could have, say you repeat 1 1 2 3 4. You could have or 1 1 1 2 3, or you could have 2 2 1 1 4. So there's so many different cases that we have to discuss. So we're gonna choose to do the opposite. So the same idea. So pretty much we draw a Venn diagram to show that. So we have 5 digits, a total number of ways. Let's go ahead and work this out to get a number, so it's easier for us to. We have a total of 30,240 ways I shouldn't put it here. Put it here. When we have 5-digit code, we either have no repetition or you have repetition. So no repetition, we have this many ways, and what we want is what if we have repetition. So we can find the total number of ways, including repetition and no repetition, by multiplication rule. So which is 10. First place we have 10 options. If we still allow repetition, the second place you can use the same digit again. So that's why we have 10 times 10 times 10, 5 times. So 10 to the 5th. And then, so a total of 10 to the 5th, that many ways, including repetition, no repetition. So the no repetition is 30,240 ways. So we take this number, subtract 30,240. That will give us how many ways with at least one repetition. That gives us 69,760 different